Hi folks, we're looking at a level-to-level, horizontally and vertically launched projectile today. That means our object will actually have an initial velocity in the y direction and one in the x direction. Now for the purposes of what we're doing, this is going to be a level-to-level, meaning the object will return back to the ground level at which it started. There are cases in which the object won't return back to the level it started. It may actually go below that level, or maybe it hits something that's above the level. In those cases, we have to do something a little different. So this is kind of a special case. It's referred to as the level-to-level projectile launch, or a zero vertical displacement launch. Now, let's start by looking at what that looks like. Now, first of all, a couple things to note: that our projectile will be launched with 40 meters per second in the vertical direction and 18 meters per second in the horizontal direction. Now, if you use Pythagorean theorem, you'll find out that it's actually got a launch value of 43.9 meters per second in kind of the x and y direction. To find the exact direction, you'd have to do the inverse tangent function with 40 over 18, inverse tangent of that, making sure your calculator is in degrees if you like the angle in degrees. And that would be the angle that's formed right here. We'll talk more about that later. Let's go ahead and get this thing started. Now I'm going to stop it right before it hits the end, but this is basically what happens. The object will go up and it'll come back down to a stop. Now, a couple of things to note. I've actually got two more objects on the page. There is a vertical object that is being shot straight up with the same velocity of 40 meters per second. And basically you also have an object moving at 18 meters per second on the horizontal. The reason I'm doing this is so that as we move through, you can see that the object still maintains the same motion as an object moving vertically and an object moving horizontally. Now, a little more detail. Within the first second of launch, the object is moving upwards. In fact, in that first second, it is going to go a distance of 40 meters minus 5. The reason it's 40 meters minus 5 in the vertical is because it would have gone 40 meters in 1 second if gravity had not been at work. And gravity actually makes things fall 5 meters in the first second of action. So basically, instead of going 40 in the vertical direction, it only goes 35. Now in that first second, the object reaches the displacement horizontally, or better known as range, of 18 meters. And so therefore the object is located at the 18 meter mark on the x direction. Now if we keep proceeding forward, we'll actually see the object is gaining more and more velocity. Oh, scratch that. Less velocity actually. It's actually gaining more height and more range. Now at this particular second, at 2 seconds, it reaches a height of 60 meters. Now if you remember, the original 40 meters per second at 2 seconds should have been 80 meters. But gravity in 2 seconds causes an object to fall 20 meters, which is why it only gets to a height of 60 meters. Those two things at play. But horizontally, 2 seconds means it's going to reach a range of 36 meters, or horizontal displacement. Now, if you notice, the velocity is basically decreasing by 10 meters per second in the vertical direction, but nothing's happening to the horizontal. That's because this thing is in free fall. And again, free fall means that there is no reduction to the horizontal direction, because there's no forces in the horizontal direction. In fact, in free fall, by definition, the only force acting on the object is that of its weight, or gravitational force pulling it down. That gravitational force causes a gravitational acceleration of negative 10 meters per second squared. Basically means the velocity is going to go down by 10 meters per second every single second. So let's go ahead and continue on and look what happens in the third second. As you can see, the object is going up and it's going to hit a height of 75 meters. Now, after 3 seconds, vertically, this thing should have been at 40 meters per second, 120 meters. It's only 75 meters. So it's lost quite a bit, actually. I'll let you do the math on that. But basically, it's not going the full 120 meters. Now, the next thing on the list, folks, is we're going to go horizontally. It is actually achieved at the 4th second a, range of 54 meters. That's just 18 times 3. Now, let's proceed to the 4th second. Something very special is occurring on the way to the 4th. As you notice, the velocity in the x direction never changed, but the velocity in the y direction is 0. Now, this is important to note. At the top of the path, if you're just throwing it straight up, it would stop going up vertically. But it doesn't mean it's going to stop its horizontal motion. So at the top of a projectile's path, its vertical velocity is 0. Its horizontal velocity is unchanged. Now, one other thing to remember, at the top of the projectile's path, it's still only got one force acting on it, and that's its weight. Therefore, it still only has one acceleration, and that is the acceleration of gravity trying to pull it back down. The acceleration of gravity the entire time, from the first all the way to the 4th second, has always been a negative 10 meters per second. And as we proceed, we're actually going to see the object starts to fall back down. It's still moving sideways because it still has the same velocity in the horizontal direction. But now it has a vertical velocity of negative 10 meters per second. And it has a height again of 75 meters. It's falling back down. And on the 6th second, as we look at it, it's going to get all the way down to having a velocity of negative 20 in the y direction and 18 still in the x direction, no acceleration in the x direction. And as you can see, basically the vector is now pointing down, and that vector's length is going to get longer and longer and longer as it goes closer to the ground. Now, at the 7th second, our object is moving at negative 30 meters per second. It is now at 35 meters in height and 126 meters in range. Now, that's because the range is 18 times 7, and the height, that's a bit weird, because here's what we have to do to figure that one out. You have to take the 40 meters per second up, multiply it by 7, and you get a number, like 280. Then you have to take the 7 seconds and see what gravity does in 7 seconds. That's roughly 5 times 49, because 7 has to be squared. That's a really large number. So those two things are put together. Now the gravity is in a negative direction, so therefore it takes away from the 280, and it only leaves 35 as a remainder. The displacement is only 35 meters. Now, if we continue on, you'll find out it only takes 8 seconds to reach the bottom. Now, at this particular point, the object has moved 144 meters. Its displacement is basically 0 because it's returned back down to the ground in the vertical direction. Its horizontal displacement, like I said, is 144 meters. And it took a total time of 8 seconds. Now, it's worth noting that in this particular case, this is very symmetrical. I mean, if you take a look, you could split it right down the middle, and you'll see the same on the way up as you would on the way down. Now, again, I want to make note that this is two motions happening at the same time. It's that vertical free fall when you throw an object up in the air and how it slows to a stop and comes speeding up as it goes back down. It's also that horizontal constant velocity that occurs in the x direction. Now, those two motions are happening at the same time. So now we're going to go take a little bit closer look at some of the things going on with equations and how to prepare to solve problems.